Over the past 50 years, data storage has seen its costs decrease by an average of 30.5% per year. And in fact, it's been decreasing pretty consistently for as long as we've had writing. And it's got a downward curve to it, which means that based on the sum of the cumulative storage fees between now and some point in the future, there is a price you could pay just once for a known period of time. And based on the rate that storage costs are continuing to curve downward, your fee would actually pay for it to be stored forever. Hi, I'm Devon James, the co-executor of Web3 Working Group, and welcome back to What Kind of Internet Do You Want? Last time we talked about why permissionless persistent storage is a problem that seriously needed to be solved. In this episode, we're going to talk about how Arweave solves it. Sam Williams had been building distributed operating systems for his PhD, and he'd had his eye on blockchain technology for some time. As he describes to Amy in her interview with him, it was his reading of a handful of books about authoritarian regimes and recognizing just how bad the world could get if authoritarians had... Well, I'll just let him explain.
If you look at history, you see that one of the most important things that those regimes need to do in order to establish themselves is to gain control of the information space. So to control the way people think about the present, and you can do that by controlling the way that they think about the past, and that subsequently changes the way that they act in the future.
So Sam knew just how important it was to have persistent, uncensorable data storage on the internet. And he was able to put together just the right recipe of pieces to make it happen. To ensure that a piece of data is stored forever, he knew that from the end user's side, it needed to require just a single one-time fee. So they needed a really innovative approach to the question of how to price that fee, knowing they couldn't let a fee market price it, which he explains in this great Twitter thread here, and that they didn't want to act as a central planner by imposing their opinion on what the fee should be, because if they got it wrong, the whole system just wouldn't be able to scale. So they decided instead to see what history could teach them. Sam and his team looked at the whole history of the cost of information storage, going back not just the past 50 to 60 years, the computer age, but all the way back to the clay tablets of Sumeria and cave wall paintings before that. They found that, in fact, storage costs have been reducing. Over the past 50 years, data storage has seen its costs decrease by an average of 30.5% per year. And in fact, it's been decreasing pretty consistently for as long as we've had writing. And it's got a downward curve to it, which means that based on the sum of the cumulative storage fees between now and some point in the future, i.e. the area under the curve, there is a price you could pay just once for a known period of time. And based on the rate that storage costs are continuing to curve downward, your fee would actually pay for it to be stored forever. But for it to work, some entity would need to accept those one-time fees and then divvy out portions of it to the parties who are storing it over time. The Arweave team's solution to this was attaching the block reward subsidy to an endowment. Whenever a block is mined, the subsidy block reward and all the storage fees paid for the newly stored data gets divided into two parts. First, to the network miners as a function of their cost for the total data stored. And the second, to the endowment. The endowment is thus able to act as a buffer for the token price changing and ensure that the majority of the fee for storing a piece of data is set aside to be paid for over time. Now, to make it all scalable, a really big and hard problem to solve. The Bitcoin community has been divided for years about how to go about this. First, the question of whether to scale at the protocol layer in the first place, and then how quickly to do so. Aside from a few other political and ultimately kind of personality-driven divides, these are the technical distinctions between Bitcoin, with 2 megabyte blocks, and some kind of recently discovered extra space made possible by a soft fork from a few years ago now being used to store NFTs on the Bitcoin blockchain. Yes, I'm talking about ordinals. Bitcoin Cash, which wants to be more focused on being a low-cost medium of exchange than a store of value, and thus allows 32 megabyte blocks. And Bitcoin SV, which basically wants to be a storage network and thus has no cap on its block size. The problem with simply uncapping blocks comes from the design of the consensus system. In order to compete to win the next block reward, a Bitcoin miner needs to store the entire blockchain. This means that as the blockchain grows, so does the cost of competing to win new block rewards, completely aside from the cost of the mining hardware itself. To solve this problem in Arweave, they developed a novel Succinct Proofs of Random Access protocol, or SPORA. For each new block, a challenge byte is selected at random from somewhere in the blockchain. Actually, they call it a block weave. And only the miners who are storing that data are eligible to generate the proofs necessary to win the block. This protocol allows miners to prove that they have stored some data, if they have it, without actually having to store the entire block weave. And they can optimize for their scale the portion of the weave that they store versus the reward for doing so. It's what makes Arweave's mining process so much more efficient. So a small home miner, just using the spare space in their hard drives, can still participate in the network and get rewarded for doing so, while a major operation that stores the whole weave on dedicated servers can get proportionally rewarded for its contribution. Now, to ensure that each node mining the weave are unique copies of the data and not just a bunch of virtual nodes or sock puppets each attached to the same copy of the data, since that would create the appearance of storage redundancy that doesn't actually exist, this protocol involves some proof of work as well. But for anyone concerned that proof of work is an inherently wasteful process, the team actually just updated the protocol this past week to optimize more for energy efficiency. This approach also makes miners optimize for high availability of the data they have stored, which makes it more useful than some other approaches to decentralized data storage, which suffer from slow initial node discovery. It also helps to solve the problem of the tragedy of the commons by incentivizing nodes to store data that is not yet widely stored, because they can give themselves a mining advantage by choosing to store it, since they'd be competing with fewer other nodes. Likewise, it helps to solve the challenge of whether everything published should be stored in the first place, as if every single node decided that a particular piece of data was not worth storing, most likely due to it being illegal to store or distribute, like pirated content or child pornography, the two things people are most concerned about, it would cease to exist. But in the sake of content that is merely controversial or offensive, there would be some parties who believed it had a right to be shared, and thus some nodes would store and mine it, and it would persist in the network. So, fast forward to today, and it turns out all this brilliant theory all works out pretty well. The Arweave network has been live and operational for a few years now. Currently, it charges about $7.60 per gigabyte to store data forever, which is proof in the pudding, because when I first started telling people about it a year or so ago, I distinctly remember it costing $8 per gigabyte. The network processes between 20 and 40 transactions per second, and there's about 150,000 unique addresses on the network, and it collectively stores about 100 gigabytes of data.
So yeah, I totally misspoke. We're in the post-process now, and I'm looking for graphics for this, and I realized that actually what I was looking at is that 100 gigabytes of data was uploaded that day. The actual weave is up to 120 terabytes.
Recently, a Masari research report projected that it will reach nearly 3,000 terabytes in the next 3 years. There's quite a bit more to Arweave that we can talk about, which we'll do so over the next two videos. First, we're going to talk about using Arweave by going through a step-by-step process of storing the videos from this series forever on the Weave. And after that, we'll talk about running Arweave. That is, turning over some unused storage space on our media server behind me to store a portion of the Weave and earn some AR tokens. So, if you haven't already, please be sure to subscribe so you don't miss those videos. And if you enjoyed this video, please give it a like and share it with your friends. Thanks for tuning in. You can find me at Devon R. James on Twitter, and follow the channel at Web3WG on all social networks. We'll see you next time.